Okay, Bismillahirrahmanirrahim. So, we start the lecture, right? And you know the title of the course, that's Digital Logic and Design, and I'm Nasir. I know how many people know me while we were selecting the courses. Did you see my name, or it was just an incident that you happened to be in this class? जी? नाम देखा था कितना ने देखा था very good. So how many people know me from seniors? Okay, very good, that's a good sign, but normally I see people they go only on the timetable, or they see their friends in one section and they try to combine their groups. But the basic idea of giving an option to you or selecting an instructor, to me, is not very much there, right? If you keep a common slot for all the instructors, then probably you have all the choice to join any instructor. So I have different theories, which maybe I will be sharing with you people. Okay, that's my email, right? That nasir.mahmood@sheets. And that's my private email. If somebody wants to share things on a separate email, but officially we like to use the Seeks email. So if you have any problem, anything bothering you, you can always email, because I'm all the time available on email. I can respond with mobile, right? And that's the quickest way of correspondence. Right? Okay, let's see how we go about. And today, basically, we'll only discuss, because that's the first lecture, and probably we've started a little late also. So today I'm going to just motivate you why we are studying this course, right? And what is this course about, and maybe I'll introduce myself also, that what all capabilities I have, what all experience I have, so that you can maximum benefit from my experience, right? And I'll try to come up at your level, right, to teach this course. And this is a very, very fundamental course, and I think I have taught it so many times. Right? I'll share my experiences, right? So I've been involved in teaching, let's say, more than 18 or 20 years in university teaching. And I'm one of the oldest faculty here, and I think over 13 years I've spent in Sept. So that's the advantage you can enjoy. Okay, let's see about the course title. Right? So, okay, my style of delivering the lecture will be very, very informal. We invite more questions from the students, right? Because they has to have two-way communication. Because I don't believe in lecturing, because when I keep lecturing, you'll be listening, and after a while you will speak, right? So in order to have proper communication, we like that you must ask questions. And now I'm giving you liberty to ask any question, any stupid question, anything you want to ask, right? Related to the course definitely, right? And you have the liberty, and okay, every time when I teach this, right, we make a promise. Because when you ask me too many questions, so what will happen? You definitely not cover the course. So I normally take a promise that you will give me extra time if required. Up till now, I've been teaching for so long, I haven't taken extra classes. But are you ready for, let's say, extra time if the syllabus is not covered? Yes or no? Yes. Very little less. Okay. So in order to maintain, right, if you don't ask questions, I will ask questions. And that's the first title, that's the first slide. So I'll keep asking questions, right? If ask me questions, पूछेंगे तो मैं आऊँगा. Okay, just to make you live. Okay, so that's the title of the course. Everybody understand, right? So digital logic design. So let's elaborate this title. What mean by digital, what do you mean by logic, and what is basically in this course, what we are going to design. So, can somebody tell me what is a digital? अच्छा, क्वेश्चन आंसर के जब भी मैं क्वेश्चन करूंगा, you just raise hand and जी आप बताइए, प्लीज जरा नाम भी बता दें, so that थोड़ी सी इंट्रोडक्शन भी हो जाए. मोहम्मद रमीज, ओके. This is circuit. Okay. Maybe not. जी आप. Okay, just closer. Anything which is processed in 1 and 0 is answer for. Anybody else know what is digital? And where this word comes, digital?
Discrete value.
Okay. So he has said the digital is discrete. Anybody disagrees to this? He, basically, okay. So can you differentiate between digital and analog? Analog is continuous, and digital is not continuous. This is a continuous signal. That's it. Okay. If I let's distinguish first. Okay, I'll be using pen input, and I'm using this bamboo tablet, and I have a pen. So whatever I write, you will see there, and then I have. That's my effort. I put an interactive board. So instead of writing it there, even I can write it here, right? And this will act as my board, right? And whatever I write will be recorded, right? So I made this efforts to install this interactive board, and this cost about 55,000 rupees, and we got it free, right? Somehow we managed to get it free for you, and that's why I kept this classes. This, so whatever you write or the students write, everything will be recorded. Right? So today I haven't configured yet. Last time I was trying to configure it by Apple, right? Because everything was configured to Windows. So I mean there's a little problem with drivers. So probably today I'll try to resolve that. And hopefully we'll be using this board as a free board. Whatever we write on the board, that by the student or by the instructor will be recorded, right? Okay, let's see what is analog. And somebody said, right, basically analog is a continuous signal. So can I say this is, what type of signal it is? Analog, right? Continuous. Or whatever, let's say if I make a speech, right? So the audio, right? What is the audio? Basically a pressure wave, right? When it goes to a mic, what happens? The diaphragm vibrates, and that's converted into electrical signal. And in normally electrical signal, we get, let's say, speech like this. ये speech का signal हो गया जी. Maybe peaks like this, maybe some frequency, and you know the basic frequency of that is I think 4 to 5 kilohertz only, right? So that's also continuous, right? So what the digital signal will look like. Square wave. Like a square wave? Okay. So he's saying my digital signal, right, is like this, which I'm drawing it in red, right? So my digital signal look like this. Is it a digital signal? B? So what is the difference? It is again a continuous. With time, it's changing, but can you find the difference?
So the scale function is the rapid decreasing and increasing. Rapid increase. So rapid increase and rapid decrease.
But just remember, it has only 2 levels. If I look at the signal at any time instant, it has only 2 levels. That's it. If it is 5 volts, right? If this is 5 volts, right? And this is 0 volts. Anytime I see signal, I find 2 levels, 2 discrete levels. Such kind of signal will be called digital. Okay. Let this digital comes from. Okay. Can you tell me what type of this signal is? G. What? Can you say this is a digital signal?
Yes, sir.
G? You can say? I'm saying no. G. Why we say it's not a digital signal? G, आप क्या कहते हैं? हाँ. जरा थोड़ा ऊंचा बोलना है ताकि everybody understand. Okay. He's saying this signal is not digital because it doesn't have two states. Because this signal is a digital two state. But okay, for a digital signal, it can have discrete values. It has discrete values, so digital. Right? It's a digital signal. How many levels it has? One level, two level, three level, four level. Only four levels are there. But still it's digital. Right? Anything which is discrete is called digital. Right? For example, if I have a torch, if I switch it on and off, what is this? Digital. It has two states, either on or off. Let's say I have three position switch, right? Three positions, 0, position 1, position 2, position 3. What is this? Again digital, because it has three discrete values. And the word digital basically comes from digits. How many digits we have? Decimal digits. 10 digits. 0 to 9. 10 discrete levels. Right? That's why if you see the digital watch, it has numbers. And they change in steps. Right? The numbers, and that's why this digital world came in. And today we see what is the digital world and how things are moving, why we are moving to the digital, why not analog? Whereas in nature, if you look at the nature, right, that's everything is analog, right? Like the audio you hear, right? My eardrum vibrates and gives the signals to my brain, and everything is processed in analog, right? My eyes, whatever image I get the image on the retina, and everything is processed in an analog way, right? Everything in nature is analog. Why we are going against the nature? Why we are doing everything in digital? Right? We'll see the reasons later on. We'll see the reason why this is preferred than this. Right? Because here, things is changing continuously with time. And it has not the discrete values. The values are any values. It's also infinite. Right? It's also, if I look at the amplitude at every time, it is varying. It doesn't have discrete levels. Right? Anything which has discrete levels will be the digital signal. For example, if I say traffic signal, it has three lights, red, green, and yellow. So what do you think? That three colors, what I should call it? Is it digital or analog? It's digital. Because, and how the computer will recognize these colors? The computer doesn't understand these colors, red, green, and yellow. How it will say it is a red light or a green light, and it will allow the passengers to go. So later on we'll see all the discrete values can be translated into ones and zeros, digital. Okay, as you were saying earlier, this signal is also digital. This is digital, but this is binary. What is this? It has two values. And normally, later on we'll see, we will be dealing with binary signals only. Right? And my levels of this signal can be any level. Not necessarily it is 0 volt and 5 volts. My digital signal could be like this. Right? It can be, let's say, my signal could be like this. Right? And this is my 50 volts, right? And this is 10 volts. Or it is minus 10 volts. So any two levels. So it's a binary. Right? So normally in the aircraft where you have noise, right? You don't have the signal 0 and 5 volts. Maybe the noise can override. Right? So maybe there the voltages are high, right? But again the signal will be digital. Right? So now you understand the difference between the digital and analog. See? Everybody has understood? Any questions, please? You can always stop me. You can ask any questions, and later on we'll see we'll have the make hearing, it's of the class learning also. And if you have seen listed the LMS, we have a number of links. We will discuss that probably in the next class. And I'll try to explain how to register in those forums, online forums. At 2 o'clock, you can ask questions. And your classmates will answer those questions, right? And in the end, maybe I endorse that question, right? And then we have other forums, right? And this, every time I introduce new things. Last time I introduced the Facebook, that was very, very effective for the students because they are always on the Facebook, right? They don't like to go on Piazza, right? Maybe all the time they are on the Facebook. So we have to care, we have to really communicate with the student the way they are, right? Maybe I'm an older guy, but I will adopt those methods where I can have a communication with you, right? And then in this course, we are introducing another thing that is online consultation. You're sitting at home or in hostel, even you can consult it. Now the distance doesn't matter because I have pen input. I can explain things on the screen where you can see on the computer or on your mobile phone, right? So we have very powerful devices like mobile phones, right? And they are big computers in our hand, right? We can utilize them, smartphones, right? And you can imagine that this is a 64-bit machine, right? 64-bit machine used to be on the desktop, very powerful machine in your hand. Only the display is limited, but rest everything is in your hand, right? So we'll see all other new options, right? And I will also ask suggestions from you how you want to learn. Right? You go by your choice, not by my choice. Okay, now it's clear. And later on we'll see the advantages why we go on the digital and why not we go on an analog. Whereas you find nature is everything is analog. And let's say rainbow colors of rainbow. What do you believe? Digital or analog? It's analog. Why? Because some people say it's analog because you have a blend of colors. It's not like that. If we say 7 is a discrete value. So whenever we are talking about discrete, it's digital. Remember that. It's very, very simple principle, right? If, let's say the speedometer of my motorbike, what is that? That's analog because that's changing continuously. But the speedometer, digital speedometer, where it's showing the numbers, will be digital. So you have to really see, and that's why if you see, I had shown you this I've shown you the digits in the very big in the digits, they are discrete values. Clock here. What do you think this clock is? Analog? No, I don't say it's analog. Anybody say it's a digital? No? Anybody say it's a digital clock? I say it's a digital clock. And that's the reason. You can rethink. If you look at the second, it is changing in steps. It's a digital clock. Basically, the appearance is analog, like we have a continuous. If my this second middle is moving continuously, then it is analog, right? But it is when it's moving in steps, discrete values, then it is digital. Keep it up. We'll put on the check and leave it as a moving in steps. One by one. 1 second by 1 second. If it is continuously between, then I am saying inside, the machine inside is digital. Because if it has gears, it has a continuous thing, then it is analog. When it's moving continuously, then it is analog. Because it's a continuous, with time is changing. But with time, it is changing one step by step. 1 second, 2 seconds, 3 seconds. The longest is 1.5 seconds, 1.25 seconds. Yeah. That's why it's so I've given you a number of examples. So where you can really understand. And now you can see very nice circuit, and you'll also learn how to make these circuits in the lab, and then you learn all other things, right? So now you understand the first part of the title, that's digital, right? And you understand the difference between the analog and digital. Okay, the second word is logic. What is logic? आपने पढ़ा हुआ है 9, 10 से सारे पढ़ के आए हैं logic. जी. Logic gate. What is logic gate? That's a logical decision. Logical decision. Basic gates क्या हैं यहाँ पे? Basic logic क्या है? And three basic logics. What is and, or and not. Okay? Not operation क्या होगा? Very simple. If it is 1, then it is 0. Right? If it is 5 volts, it's 0 volts. If 0 volts, it's 5 volts. And how they are not is basically made out of the transistor. अभी आपने electronics से नहीं शुरू की है. अच्छा, that's why. And मजे की बात ये है कि ये जो gates होते हैं, they are made of transistors, right? And the transistor act like an inverter. अगर उसको मैं 0 volt देंगा तो आउटपुट पे मुझे क्या मिलेगा? 5 volt. अगर उसको मैं 5 volt दूंगा तो आउटपुट पे मुझे क्या मिलेगा? 0 volt. क्योंकि electronics का background नहीं है, I don't want to give that example, right? So logic is simple logic, right? And in this we have combinatorial logic, and then later on we have higher order logics, right? Where we make all the arguments. In computer science, the logic sense is a very, very powerful unit, right? Here we study only the very simple logic, right? And the simple logic here, the basic gates here are the and, or, and not. And everybody understand what is the AND gate or AND logic? What is the condition for AND logic?
If both are true, then it is true.
If both are true, then my output is true, right? Or में क्या होता है?
If either is true, then it is true.
Either one of them is true. So it's like a circuit. आपने circuit analysis तो पढ़ा है ना? So AND is like this, right? AND is like this. That if I have, let's say, a battery, right? Maybe a DC battery, and I have a switch here, and I have another switch here, and I apply it to maybe a bulb here, right? And I close the circuit. Let's say this is switch 1 and this is switch 2, right? So when this switch, let's say I have 12 volts here, and maybe this is a DC bulb, right? So when this bulb will be on?
So then those switches are closed.
If I put the switch 1 on, bulb will not be on. The output will not be high unless both the inputs are high. If I close these two, then output is high. Right? Because the light on and off is again two states, digital. Right? And switching on and off is again digital. Right? So my input is digital, output is digital. And what will be the OR circuit? OR circuit कैसा होगा? और parallel में आ जाएगा. ठीक है? So I have this same battery here, right? And now I have two switches which are in parallel, and now I have connected that bulb here, right? And I have connected this bulb here. So let's say if I put switch 1 on and switch either one of them, switch on कर दूँगा तो क्या बात कर लेगा? बल्ब ऑन हो जाएगा. ठीक है? क्या दोनों ऑन कर दूँ? ये ऑन हो जाएगा. क्या switch 2 को ऑन कर दूँ? So the logic here is that if any one of them is on, my output is on. Right? So later on हम इसको देखेंगे. और एक नॉर्मल जो ट्रांजिस्टर होता है वो मैंने क्या कहा, नॉट गेट होता है. तो उसको 1 देंगे तो आउटपुट पे 0 मिलेगा. राइट? सो द सर्किट इज लाइक दिस. एंड गेट का मैं अभी हम इंट्रोड्यूस करेंगे लेटर ऑन. तो सिंबल इस तरह का होता है. ठीक है? सो आई हैव 2 इनपुट्स, राइट? लेट्स से दिस स्विच 1 and switch 2, I say this is X input, this is Y input, right? And if my both inputs are 1 1, then I'm going to get a function equal to 1. Right? Otherwise it will be 0. ठीक है? और गेट कैसा होगा? उसका सिंबल कुछ इस तरह का है. ये कुछ ऐसे गोल और ये भी इस तरह. ठीक है? ये भी गोल. So this is an OR gate. Now if I provide 2 switches, Either one of them is on, my output is going to be on. और NOT gate क्या होता है? Is simply a NOT gate here, right? If I provide X, I get X prime, which is not. If I provide 1, I'll get 0. If I provide 0, I'll get 1. तो ये हम डिटेल में हम स्टडी करेंगे. तो अभी आपको कोर्स का थोड़ा सा पता चल गया कि we are dealing with the digital world, right? We will be dealing with everything in discrete, right? And then we apply a logic, right? And then lastly is the design. What kind of design we do, right? So what kind of design we do? So in design, basically, we'll be only focusing on two designs, right? One is called the combinational logic, right? Combinational design. The other called sequential logic. Right? If we go in detail, they are just introducing just a little bit, right? So my first combinational design is where my outputs are purely dependent on inputs, right? जैसे मेरे बल्ब था, वो उसकी आउटपुट किस पे डिपेंडेंट थी? स्विचेस पे. So that's a combinational circuit, right? या कोई एक एडर है, उसको मैं दो नंबर दूंगा तो आउटपुट में क्या देगा? Depending on input. Output is dependent on input. So such kind of circuit is called combinational. ठीक है? और sequential circuit में क्या होगा? एक मेमोरी एलिमेंट भी आ जाएगी कि पहले क्या था, ठीक है, लास्ट टाइम क्या था, उसके मुताबिक आउटपुट चेंज होगा. जी जी, कॉम्बिनेशनल प्लस फीडबैक will be a sequential circuit. In that, a memory element will be there, a feedback will be there. पहले आउटपुट क्या था? Like a counter. काउंटर में क्या होता है? वन के बाद क्या आएगा? इसका मतलब वो पहले वन पे था तो हुआ है. It depends on the previous one. So I'm not going in detail. We will discuss. That's the whole course basically. We will be discussing the two designs. You learn these designs, which are the basic building blocks of your computer. Right? और फिर एक language भी हम सीखेंगे, which is called the Verilog hardware descriptive language, where you can design things sitting on the computer and writing a text. And you will be designing computers and traffic controllers and you can design anything, right, in the world. And so now you can understand what we are going to study in this course. Digital, we are dealing with discrete things. Logic, we are dealing with basic logic. And out of these basic logic, we will develop more logics, right? And then, based on those, right, and this initial part you have already studied in maybe 9th, 10th. Even the computational logic also, I think we have studied in FSC level. Because I've been teaching my kids, right, I know what you have been studying. But this is a very fundamental course. It doesn't have any prerequisite. You start all over, right? And we try to go in the initial things a little quicker and spend more time on design. Because that's the thing we want. That if you learn this knowledge and then you apply this knowledge in your life, that should affect, right? And we'll always correlate theoretical knowledge with practical life, right? That I be relating things with the practical life, because that's important. Knowing a theory and doesn't you apply that theory is of no use. या आपने जो नॉलेज गेन किया है उसको जब तक आप सोसाइटी में अप्लाई नहीं करेंगे, अपने लिए अप्लाई नहीं करेंगे, इंस्टीट्यूट के लिए अप्लाई नहीं करेंगे, उसका कोई फायदा नहीं. So our focus will be basically to apply the knowledge. Okay? So quickly, let's say, so before we start the course, today we'll only talk about the motivation, how you motivate. So now you could see that we are living in the digital age. And I'll give you a few examples. Right? Everything is, earlier you had analog transmissions, where you have a lot of noise, everything, right? You have digital analog phones. There's a lot of noise, people have to shout, right, when they're speaking. But on the digital phone, on cellular phone, it's very quiet, you're talking very easily and all that. So we have an advantage, right? So let's give some example that we are living in the digital age, everything is getting digital, right? Like look at the camera, right? Earlier we have photographs and we had all, which is analog, basically the light impacts and give the, now we have digital camera, right? You can take as many pictures you want, right? You can store them on network. There's no problem of storage also, right? And things like that. So everything is revolving. We are living in a digital world, right? And probably you haven't seen the analog part. I have seen the analog part, right? Where a lot of things were in analog and then they were transformed into digital. And you'll see the reason also. So let's look at some of the devices are in our surrounding. So like digital watch, right? I give you example, right? But these days we have very modern watches coming. Like Apple is what they will launch the iWatch, right? And where everything is itself a computer. Right? On the wall, it is monitoring your health conditions, it is giving you weather conditions, it is giving you email, right? You can even make a call, everything is coming on the desk. It's a watch. Right? So like this is another model. So maybe that's the next model, I don't know, but I've just given you the thing. Right? So digital watch is one, right? And then camera. And you know these cameras, they are enormous features, right? Everything is stored, you can watch, retake as many pictures you want, right? Store it on the network. It's enormous features. Right? Then you have computers, right? Computers, modern computers, right? You can see the iMac here. The whole computer is inside the screen, right? You have wireless mouse and everything, right? Everything is shrinking, and I told you that even the mobiles, the new mobiles, they are very, very powerful computers, right? They are 64-bit machines. You used to have a big computer on your desktop, right? And you can enjoy all the features of that big computer in your hand now, right? So let's see some of the other devices like digital TV, right? So earlier we had analog TV with a lot of noise and everything. Now you have satellite receptions, right? You have the digital transmissions, where you have a noise-free pictures, very crisp pictures and all that. So everything is moving towards digital. Even the satellite communication, right, is digital, right? Because transmitted such a long distance, right? When it is received, all the noise is terminated, right? The advantage of the digital is that in first stage, the noise is cancelled, right? But in analog, let's say if I have a mic, if I speak to it, analog, and then it goes to an amplifier, and it goes to a speaker, so what will happen? If there is a noise, a fan is there, right? It has a constant noise. What will happen? It will add to that speech, right? And on my speaker, I will listen to the humming noise of the fan also, right? So the noise is not is also amplified. The very simple example here, let's say if I have a signal here, speech here, right? Maybe a speech here like this. So if my noise is there, so what will have? It will ride on noise. It will corrupt my signal. It will ride. And if I amplify it, goes through the amplifier, right? What will happen? Everything is amplified. My noise is also amplified. So I'm not getting an advantage. The basic purpose of amplification was to amplify the audio, not the noise. But this analog, everything is, because it's a continuous thing, it will be amplified. But in digital, it is based on 1 and 0. It's 2 levels. If noise was there, in the next stage it won't be there. Because it has again 2 levels. 1 and 0. 5 volts and 0 volts. Right? So that's the advantage. Okay, now you can understand the advantage of some of the devices, like DVDs, right, where you have a very crisp, in one DVD you have a full movie, right, you can enjoy the quality of the DVD. Movie is much better than we had on the VCRs. We had that VCR tape, right, most of the time it just goes that on the tape and you have to clean the head and all that. So everything is eliminated. You are living in a digital world. Right? So I'll not take much. At 55 I'll just close, right? So these are some of the examples here. I quickly go on. Look at any field, everything is based on digital. All the communication, all your cellular phone communication is digital. It's a computer. It talks, and only not computer, it can handle your voice, it can handle your money transaction, it can do all other things, right? All your traffic control, space guidance, medical treatment, weather monitoring, internet, right? Now the internet has even gone into your things. Right? smaller thing, anything has an IP address. You can communicate to the World Wide Web, right? What is internet? Internet, they say, is a really massive, it's a new thing that you are connected to the whole world of computers through these routers and through interconnects. So that's the biggest invention and all that. Right? And then it looks at other things like industrial automation. All the whole processes, they're automated, right? Like car manufacturing, everything is done through computers and robots, right? And then you look at the automobiles. Like I just give you the example of the modern automobiles. Maybe they're making the future cars where it will just go on the road also and can fly, right? You can even swim and all that. Look at this automobile. This is a motorbike, right? Where it is balancing on two wheels, right? What can balance on two wheels? It doesn't fall down like this. Even somebody hits it, it doesn't fall down. What is the principle behind that motorbike? They are all control systems which we are going to study, but the basis of that is digital. Because in the digital control, right, you are able to make something. Like Segway, you have seen the Segway, when you stand on it, you don't fall out, and the wheel, the wheels move and you move forward. Right? So all such things are possible in the digital world. Like robotics, right? Now the robotics have the feelings. They can smile at you, they can dance, they can do a job of a receptionist, right? Sitting in a robot, you can take your ID card, you can do everything. Things are getting intelligent and everything. Right? So I just stop here. I think unfortunately, so we keep continuing. So I mean that's the last slide, right? So this course, sorry. So this course is basically focused on two things, right? If you look at the objective of the course, that is, we are developing a basic understanding of the digital systems of life. And we later on see everything around us is digital, right? And if we want to really understand these things, want to work, we can design things, we have to really understand. And that's the lowest part of the hardware, right? There's a computer, which is a complex machine, which doesn't have the circuit. It has only combination of sequential circuit. It's a sequential machine, basically. Nothing else. A computer is nothing but a digital machine. That's a live example of digital machine which works on the digital logic, right? And which you are going to study. So, inshallah, we'll continue this motivation. Hopefully, you are motivated for this course, because unless you're not motivated, you can't really learn. And later on, we'll see, I'll give you different tips of how to get good grades also. Right? In the next lecture, guide you, because you have spent 1 year, but still I know that you haven't understood the semester system. You haven't understood, because we have been in the semester system for a very long time. We have been teaching you this. I can give you a very practical tips how to get good grades and how to learn basically on this subject in depth. Okay, thank you very much.